Hello there guys, welcome back to another epic inexorable maths video. In this video we're looking at using our differentiation knowledge for hyperbolic functions now to deal with some more complicated differentiation questions with hyperbolic functions. So things like using the chain rule, using the product rule, etc. with hyperbolic functions when differentiating them. So let's just dive into the first question. Okay, we want to find the derivative of cosh x cubed. Let's think about how we can do this. So you could maybe you're kind of a wizard and you can kind of just do it. If not though, we can do this with the chain rule. So we could let u be x cubed. Again, you might not need to do this, but this is a nice way. This is a way that you can be certain that you've got it right. So if u is x cubed, then we can say that du dx is 3x squared. I hope that we can agree on that. If u is x cubed, then our kind of y, if we call this whole thing y, then y is just cosh of u. So dy du would be shine u, right? Because the derivative of cosh is shine. And then to get dy dx, which is what we would like, this can be dy du times du dx, right? Because the du's would cancel out. We know dy du, it's shine u. We know du dx, it's 3x squared. So that means that dy dx is just 3x squared multiplied by shine u. And u is x cubed, so I'm going to put that back in. And this is our answer. So you might have been able to just immediately see that, right? But that's kind of how you do it. So as you know, it's very, very, very similar to just normal differentiating, like sine of x cubed or cos of x cubed. It's the exact same thing. All right, on to the next question. So this is the next question. We've got shine x over cosh x. Now this is also known as tan x or tanh x, if you're inclined to call it that. I'm not a huge fan of calling it that. I prefer tan. But I digress. Maybe you want to differentiate shine x over cosh x, right? Because I made a video about differentiating the hyperbolic functions, but it doesn't have tan in it, so let's just do it right now. We can do this. You can either break it down into its exponential definition, maybe that's easier, but let's just do it like this as a quotient rule, because why not? Maybe we're a little bit mischievous, I don't know, so we're going to do it. So we're going to let u be shine x, and we're going to let v be cosh x because it's on the bottom. So the one on the top is always u, the one on the bottom is always v, guys. That's how it is. Okay, and then that means that du dx is just going to be cosh. Amazing. And likewise, dv dx is going to be shine, isn't it? Because they just swap. Okay, lovely. So that's what we've got so far. It's not too bad. Okay, and then we substitute into the formula for the quotient rule. So dy dx, I won't actually write down the formula for the quotient rule, hopefully you know it. It's going to be du dx times v first. So cosh times cosh is cosh squared x. Minus u times dv dx, so shine squared, so minus shine squared. And this is all divided by v squared. V being cosh x, so this is divided by cosh squared. Okay. So how can we maybe go about simplifying this? Well, you might know that cosh squared minus shine squared, just like how cos squared plus sine squared is 1, cosh squared minus shine squared is the number 1. That just comes from the fact that, remember, you may know this, remember that every single identity trigonometrically is the same as the hyperbolic corresponding identity. So take any trig identity that you want that has sine, cos, tan, anything else, you can have the exact same identity with hyperbolic functions with one exception. If you have a squared sine term or an implied product of sine terms, so like sine A times sine B or something like that, the hyperbolic version needs to have a negative in front of that term, if that makes sense. So we know that cos squared plus sine squared is 1. Because the sine is being squared, The hyperbolic version is going to have a minus sign there. So this is the same as the number 1 here. And again, you can see this identity if you break this down into its exponential definitions. But this is the number 1. So this is equal to the number 1 divided by cosh squared. And you could leave it like that, but a more common way to write this is sec squared. Because 1 over cos is sec, 1 over cos squared is sec squared. Well, 1 over cosh squared is sec squared. And that's the answer, that's the derivative of basically a fan. All right, guys, to finish off, I've got a bit of a doozy for you. We've got I don't even know what doozy means, e to the power of sine 4x. Okay, kind of crazy because the sine is in the power, but it's fine. It's just going to be the kind of chain rule, but maybe do it a little bit twice. Again, you may be able to just see what this is, but we're going to go hardcore through it. So what we will do in our heads, though, is the derivative of sine 4x. So we're going to let u be sine 4x, okay? Because then we can have e to the u, and then that's quite nice, because that's, again, this is chain rule, typical stuff. So du dx, you could do another, like, let, I don't know, v equal 4x or something, and try and differentiate this, but I'm going to assume that you can do this one in your head. This will become 4 cosh 4x. Hopefully that makes sense, okay? All right, now if y is e to the sine 4x, then that means that we can say that y is e to the u, because u is sine 4x. Okay, and then we can get our dy du, which is just, again, it's just e to the u, because e to the u will differentiate to itself. Lovely, okay, now as always, dy dx here is just dy du multiplied by du dx. Once again, because the du's will cancel. So dy du is e to the u, and du dx is 4 cosh 4x. So times 4 cosh 4x. And we can clean this up a little bit, can't we, guys? So the whole thing, dy dx, this is going to be equal to 4 cosh 4x times e to the power of, and remember what u actually was, it was sine 4x, so this is e to the power of sine 4x. We kind of got really small handwriting towards the end, but that's the answer. So guys, hopefully that helps contextualize what exactly you're supposed to do when you come across a question involving this sort of thing, differentiating with hyperbolic functions. Hope that helps, and I'll see you in the next video.